Lesson 9.8, the surface area of a prism. Okay, so here's the deal. I'm going to start with the most basic thing about this concept. What does the surface area mean? If I have that box right there, pretend that box was closed, the lid was closed, I've got myself a box, whatever. There's my box, okay? What's the surface area mean? Tell me. Sladen, you had your hand up.
Surface area meant the area, how much area can that, how big the surface is.
It's how big the surface is. Here's the thing. Think of it like this. How much wrapping paper do you need to wrap that gift? What is the area of the entire outside of the three-dimensional object? That's what surface area is the total area of all the sides of the object. How much wrapping paper does it need exactly? So in this situation, here's the deal. I'm going to show you a couple of ways of doing this. Okay, I'll show you a couple of ways. One is for you to do what is called draw a net. You can draw a net. Drawing a net of a three-dimensional object means that if you were to take scissors and cut the edges of this whole object so that it's laying out flat, like this, this thing's net would look something like this. Oops. Oops. Something like that. Does that make sense? It doesn't look great. I'm telling you, I didn't draw that very well. But I cut out the sides, so all of a sudden you can see how many sides are there on this object. How many sides are there on this object? 6, right? And so then if you knew the dimensions of the object, then you could find the area of each one of those squares. I'll show you another one, a much better drawing of that. So here's my object. We'll do a nice, long, skinny box. Okay? This net would look something like this, for real. You see what I'm talking about? I need you to look. Do you see what I'm talking about? This could be the front. This could be the top. This could be the back. This could be the bottom. Right? And this is the left side, and this is the right side. I find the area of whatever this thing here is. I find the area of this thing, and then I find the area of this thing, and then I find the area of this thing, and then I find the area of this thing, and then the area of this thing, and then what do I do with all those areas? Add them together. That's the total area of the object. I would just need to know the dimensions of the object. For example, if on this object up here, I was to tell you that this right here was, say, 10 inches, and this guy right here was 4 inches, and the height was 4 inches, then could you tell me the surface area of the whole object? The answer is yes. Here's one way. If you know that this right here is 10 inches, right here, if that's 10 inches, and then this is 4 inches, and this is 4 inches, can you tell me what the left and the right, the area of the left and the right are right now? What's the area of the left? 16, right? 16 squared inches. What's the area of the right? 16 squared inches. What about the front?
100.
Not 100. Well, look, it's 4 is right here, right? We already decided that's 4, and this is 10, so then it's 40 squared inches. And then what would the top be? 40 squared inches. And then the back would be 40 squared inches. And the bottom is 40 squared inches. So 40 plus 40 plus 40 plus 40 is 160. 160 plus 16, 160 plus 16 plus 16 comes out to, what is that, 192 squared inches? 6, yep. That would be the answer. That is the surface area of the whole object. You have to find the areas of each of the sides, and you're good. Does that make sense? One thing that you can do, drawing a net really only helps you visualize it so that you can see what the object looks like. Another net might look like this. You might have a triangle like this. Oops. Okay, you see the object? What kind of object is that? Prism. Triangular prism. How would that net look if you were to undo that thing? How would that net look? Well, let's take a look. Tell me if this looks like what it might look like. First of all, does that look like these sides here? Does that look like that might be the 3 sides? Okay. What would I need to do about the top and the bottom? What about that? Can you see where if I was to flap this thing up and flap that thing up and then fold this guy right here, it would make it? It would make the same object. Do you see what I'm talking about? Can you visualize it? I think I drew that good enough that you could visualize it, right? So this right here, this thing here is called a net. It helps you see what the sides are, right? Helps you see what the sides are. How do you find the area of a triangle, though? Do you see what I'm talking about? Like, see this triangle? What if I drew that triangle for you, and I had this, and I told you that right there was 3 inches, and that the base down here, well, hold on, we'll draw it up here. That thing right there was 2 inches. Could you tell me what the area of that triangle was? What is the formula for finding the area of a triangle? Base times height times half, or divided by 2. So what's the base of that triangle? No, what is that 3 showing? No, what's that 3? What is that 3 showing? Isn't it showing the dotted line down there? Is that dotted line the base? Is the dotted line of that triangle, let's draw the triangle over here. We're going to draw the triangle right here. And it goes like this, right? That guy right here, this right here is 3 inches. That dotted line is 3 inches. What do I need to know? What do I need to know in order for what is that showing you? What is that dotted line showing you? It's showing you the height of the triangle. It's showing you the height of the triangle. Well, where's the base? Don't I need to know what this is? Can you tell? What is that thing? Oh, if it's 2 up here, then it would be 2 down here. Agreed? So then this right here is 2 inches. So then it's base times height divided by 2. What's the base?
3.
What's the base? 2. What's the height? 3. 2 times 3 is 6 divided by 2. 3. Then the area of that triangle right there is 3 squared inches. That's the bottom. If the area of the bottom is 3 squared inches, what's the area of the top?
3 squared inches.
3 squared inches, right? What do you need to know about the rest of the triangle in order for you to tell me the rest of the surface area? What do you need to know? What do you need to know? What is the other objects left in this object? What are the sides? Rectangles, right? So do I need the base and the height, or the length and the width of each one of those, right? We know that this guy right here, we know that this thing right here is how long? 2. Okay, so what if I told you that this guy here, if I told you that he was 10 inches, then could you tell me what that guy in the back was? Where would he be? 20, right? 20 inches squared in the back, right? And then what if I told you that this right here was 3 inches, that this line right here was 3 inches? Have I given you enough information to tell me what the back there is? How many squared inches is the back? It's 30. Why is it 30? Look at that object. Look at this. I'm going to color it in green so you can see. I want to know what that side is. Have I given you enough information to tell me the area of that side? Yes. Tell me the dimensions of it. It's 3 by 10. I didn't tell you that this was 10. How did you know that this thing right here was 10? Oh, if this is 10, then this is 10. And then this is also 10. Right? Right? So then 3 by 10 is 30. 30 squared inches. So if the bottom, so here's the deal. This is what you're going to do on your homework. You're going to write down the two sides. You're going to write down all the sides. You're going to go top, bottom, front. Is there a back? Not really. There's a left and there's a right. Is there a back? Do you see the object, how there's a front, there's a left, there's a right, there's no back? Do you see that, Slade? Okay. So the top, how big is the top? How many square inches was it? Do you remember? We did this. 3 squared inches. If the top is 3 squared inches, then the bottom is also 3 squared inches. What did we decide? Well, can you look at that? Have I given you enough information to tell me about the front? Have I? What do you need? You know that the side here is 10. You know that that's 10. But do you know what this is? Did I tell you what that was? No. This is 2. But look, if I want this object here, this orange object. See the orange one now that I'm drawing? Maybe I should make it a little thicker. If I want this object, do you see the orange, the front? Do you see it? What have I told you about it? I've told you something about it. What do you know about it? The side is 10. You know that this right here is 10. What, don't you need to know what this is or what this is? Don't you need that? Have I told you what that is? Where? Where? No, that 3 is dealing with the height of that triangle. No, that 3 is for the back here. That's for a completely different triangle. That has nothing to do with the front here. That does not tell you what this is, does it? No. No. I haven't told you yet. We'll say that it's 3 1/2 inches. Okay, so then what is the area of the front? What is it? 10 times 3 1/2? 35 squared inches. What's the left? Did I give you enough information to tell you about the left? The left is this guy, right? Right, in the back? Back left? What's the dimensions? 3 by 10. What's 3 times 10? 30 squared inches. And what about the right? Have I given you enough information to do that? What is that? 20 squared inches. What do I do with all this information? Add it all up. 20, 30, and 35, so 65. 85 plus 6 is 91 squared inches. That would be our total. Does that make sense? Okay. Let's give you guys one to do. First of all, I want you to draw a net of what I'm about to draw, okay? I just want you to draw a net. You don't have to find me the dimensions at all. I want you to unravel this, lay it out, okay? Yeah. That is a triangular pyramid. I want you to draw me the net for me. I want you to draw that net for me. Then I want you to draw this net for me too. I just want you to draw the net for me. Here's number 1. Oops. Here's number 2. I'm going to draw this net for me then too. Draw me. That's number 3. That'll be good for now. Draw me those 3 nets. Try and visualize it. Is there any math here? Is there any numbers here? No, it's just you. Can you see it? I'm going to show you. Okay, it's number 1. Number 1, if you unraveled that, it's going to look a little something like this. Right? There is the bottom, right? And then when you undid it, it's going to look like this, and like this. That's what it would look like. And can you now see what would happen when you flip up the sides? You see when you flip up the sides what it's going to look like? That it would look just like this? Do you see it?
Yes.
You see it? Okay. Number 2 would look a little something like this. There's our bottom again. Except this time it would be, oops, it would look like this. You see what I'm talking about? And then when you flip the sides up again, you've got yourself your pyramid. Do you see it? I need you to be able to see it. If you can't see it, then, we've got to talk about it. And then this last one down here, lots of choices for this one. I would have probably drawn it like this. And then gone like this, Drawn poorly, but you can see that right there. That's it. You could have also. What about this? I'm going to show you something. What if I drew this? What if I had it like this? Here's my object again. Okay, you see the box, right? And what if I drew it like this? Okay, you see that's the sides there. And then I have it right here. That works. And what about this? Does that work? Do you see where I can roll it, and then lid? Do you know what I'm talking about? Or I could do, what about this, and I have it right here. Wouldn't that still work? Roll it, and then lid, right? Right? What if I have this object here? I don't know if I did this one yet for you or not. Oh, let me draw it like this first. Right, there's my triangular pyramid. It could look like this. Right? And then it could be over here. I have a question. Does this work?
No.
How come? Right. When I roll it, ooh, the other side. So it needs it over here, right? And now I could flip the lid. Okay. Look at number 2. On page 454, look at number 2 on page 454. It says find the surface area. The object looks do you agree it looks like that? I've got it turned around a little bit, but it looks like that. They're asking for the surface area. If each one of those blocks is just 1 by 1, can you do the math?
Yeah.
I want you to all write down the answer. What is the surface area of that object? What is the surface area of that object? Write it down. It is. It's an area. It's surface area. Number 2 on page 454. I'm going to show you what you should have done. Look here. This is what I would have done. I would have said, okay, what are my sides? What are my sides? Front, back, top, bottom, yes, left, right. Of course there's a back. But the back of the whole thing. Right? Look. What is the front? Let's do the front. I'll do it in gold here. Here's 1, here's 1, here's 1. Yes? So the front is how many? 3. The front is 3 squared centimeters. Yes? What's the back then? What would the top be? The bottom? What about the left? 1, right? And the right is 1. Add them all up. What do I got? 14 squared centimeters. Does that make sense? Okay. Do number 3 there. Let's look at number 3. That is a rectangular prism, yes? In fact, it's a cube. How do you know it's a cube? All 6 sides are identical, yes? So then, when we do our little, our guy here, and we know that each one is 2, right? So we have top, well, I'll just go like this. Top, bottom, left, right, front, back. Which ones? How much is each one? How much is the surface area of each one? 4. 4 squared centimeters. So 4, 4, 4, 4, 4. What's 4 times 6? How many of you got 24 squared centimeters? Okay. Nothing changes just because the numbers get bigger. It's the same concept. It's what's the area of the front, what's the area of the back. If it's triangular, you got to find out the areas of the triangles, right? You got to use the formulas. We've done this. We've done this. Notice that for number 8, Mr. Jang, does it ask you to draw a net? It might be, for real. It might be. But you don't have to do it, right? Especially since you can see that like the front and the back are going to be identical. You can just figure out what the area of the front is, you know what the back is. And then you want to call it maybe like left, top, and bottom. There's no right or whatever, right? You just got to, it doesn't matter what you call it. You just got to get all 5 sides, right? How many sides does number 8 have?
5. Oh, number 5?
Look at number 5. How many sides does number 5 have? 5. What about how many sides does number 11 have?
6.
Can you see the 6?
Yes.
Rectangular prisms have how many sides? 6. Triangular prisms have how many sides? 5.
Number 5 has 6.
Yes.
Number 8. So if you want to not talk from the side, no, we would meters is 0 side for 50 times.
What number?
8.
Number 8. What's the height of that triangle? 8. What's the base? 15. So do you just go 8 times 15 and that's what your answer? No, it's a triangle. Divide by 2. People, you can't forget that, right? When you find the area of a triangle, what do you have to remember to do? Divide by 2. Right? 15 and 17 have, right, 15 times 17, right? No, 15 times 17. What's 17 got to do with the other triangle? Nothing.
And for the
Yeah. I think you guys can do this. I'll give you your homework. It's a different brand of math here. All right. Page 455 to 456. 4 through 10 even. Good. And 22 to 29 even. I didn't give you very many. So, it should be okay.